So welcome everyone. Today we are taking this opportunity to introduce Pyrsia to you, an attempt at securing your software supply chain. Let me introduce myself. My name is Sudhindra Rao, and I am a development manager at JFrog, doing all things related to binaries and package management and all that sort of things.
Hi, everyone. So my name is Chris Kroner. I'm a director of engineering at Docker, and I'm excited today to present Pyrsia as well to you.
So we have been living in this world where we are delivering all this software, we are using all this software, but we really are in a bad state of affairs in terms of how that software is built and delivered to us. Supply chain, the most talked about topic in the last 2 years, it also has affected software supply chain, software everywhere. So let's talk about how dark that situation is. So if you have been reading the news around this area, in 2017 there was a breach in the Equifax data center that compromised millions of users data, and it was because they did not update Apache struts in time. There was a vulnerable version that was exploited, and a lot of data was compromised. That's pretty sad. Most of us might remember this. It was not too long ago, right before COVID. SolarWinds was the most talked about company when their attack to their system or their software manifested in many places, and it's still there are places which are vulnerable to the same exploitation. In recent history, Log4j and Log4Shell have been the most talked about vulnerabilities, and how people are still struggling to update their software to cover some of these. And these are only the few things that are on the top of our mind when we talk about software supply chain. There are so many other systems which are compromised on a daily basis that we don't hear from news or we don't know of. Recently, when I got a new mortgage, I signed up with a company, and now I have received a mailing from a company that I have not heard of, and they have a data breach. So there are many such instances where data breaches are affecting us, and software supply chain security is kind of front and center, even though we don't pay much attention to it. When building software, we routinely consume stuff from open source packages from NPM, PyPy for Python, and Ruby gems for Ruby. There are other similar systems like Maven Central for Java and other systems, and we have implicitly trusted them. But how do we trust them? We don't have a clear answer to that question. And why do we trust these companies or these particular installations? Again, we don't have a clear-cut answer. We just trust them because we have been doing that, and we just trust the mechanism that they have built for signing and submitting packages. That's all. We don't have a way to verify them in an automated fashion. So essentially, we are living in the wild west, where we're just picking up thumb drives we found on the street and plugging it into our production systems, right? And that's a pretty sad state of affairs. We need something that helps us navigate through this mess, for a lack of a better word, and get a better handle on what we are building, how we are building it, what all pieces come together in the end production system. There has been some work that has been going on in defining what are we actually looking at, what are the systems that actually deliver software. So if you look at this simple diagram of a software supply chain, you'll see that there are eight possible stages in this system that are vulnerable to attacks, and every single one can cause disaster to the end product. Imagine if you are using a healthcare system and that was attacked and that was compromised, then all of your data and the diagnostics and the healthcare output that you were looking forward could get compromised, and could mean a lot of harm to individuals and society. So what do we need? We need something that helps us build a supply chain that is automated so that we don't have to spend a lot of energy in verifying, because that is the main thing that is stopping people from doing this on a regular basis, the effortlessness that they're asking for. We need something that we can go back and trust. We need something that we can quickly and easily verify. Currently, it's like a black box, and that can't happen. And we need something that keeps running even in spite of failures on the network, and US East going down or NPM going down. We still need to be able to build software and deliver it regardless of all these failures. And when building this presentation, I thought the Avengers characters were a good fit for these metaphors. I hope you find them as relevant as I found, and have a chuckle. So that gave us enough motivation to actually come up with a solution, and we are calling that solution Pyrsia. When we talk about Pyrsia, we want from the beginning for it to be secure, and that has driven how we are starting to build it. We want something that is reliable against network attacks, reliable against network failures, reliable against all the attack vectors talked in the salsa diagram, and we believe that this network cannot be owned by one single company. It has to be open, and so we are building it out in the open. Allow us to introduce Pyrsia, and you can go to that to our GitHub page to find out more, and we'll talk a little bit more about Pyrsia and the details and what it is. So Pyrsia is a binary distribution network, and it relies on peer-to-peer technology and for building and downloading packages. It also allows you to connect to trusted package registries so that you can build on that trust and build a better distribution mechanism for packages that you're using daily. Pyrsia is also intended to be a system where you can build a software independent of the contributor's laptop or machines, and you can build it in a way so that it is verifiable and people can trust it going forward. Where did we come up with Pyrsia? So in ancient Greek, they used a mechanism of lighting up torches to signal danger or adversaries, right? And they used a set of two sets of torches to signal some Greek alphabet, and every Greek alphabet meant something for the people you're communicating with. And this was a distributed communication mechanism, and talking about imminent dangers. So we thought that was a good metaphor for what we are building, to signal where software vulnerabilities are and which software you can use. So we thought it was a good metaphor for Pyrsia, the software that we are building. How is Docker involved? And I would like to hand it over to Chris. Yes.
Thanks, Sudhindra. So you're all at DockerCon and you already know this, but Docker is a key part of the software supply chain. People use it on weekends for hacks. People use it at Fortune 500 companies and build entire, the biggest companies in the world rely on Docker in various different ways. So there are millions of developers who rely on Docker and Docker's trusted content. When I talk about Docker, here I mean the Docker engine, Docker desktop, but also the Docker official images and Docker trusted content. And as Sudhindra said, it's really a case of companies are building their businesses on top of this open source software. And it's really, really important that we make sure that the supply chain is secured through things like Docker, so that these companies are less vulnerable to these various different types of attacks. So why is Docker involved in this specific project? Well, we feel a responsibility to help build and integrate with secure software supply chain tools. What I mean by that is that we know that Docker has a lot of people who use it, and we're in a good position to help get these products out there and get people using them. We also know that we're not the expert in every single domain, and so working with people and on different projects and helping them all work well together is the way that we make this the software supply chain more secure. We think it's really important that these tools are easy to use, and that's what Docker is really good at, is making things easier to use. My favorite example to give is PGP or GPG, the open source version. It's really, really fantastic technology, but it's so difficult to use that it's kind of failed in the mainstream. Nobody or very few people actually use them because they're just too difficult to use. And so making these things ubiquitous and easy is one of the most important pieces of solving the secure supply chain. And a piece of this is, as I said before, the Docker trusted content. So Docker official images. When you do a Docker pull Golang or a Docker pull Ubuntu or things like that, those images are used across the world by millions of people to build lots and lots of different systems. And so making these images available on different distribution mediums is important for people.
So how does Pyrsia integrate with Docker? And that's the first problem we started solving. You're going to see a short demo where you'll see how Docker and Pyrsia work together, how you can still continue to use your Docker commands like Docker pull image, Docker build image, and so on, and use the power of Pyrsia and also use the power of Docker to get those images. So our intention was to ensure that your CI/CD chains do not break just because you are adding Pyrsia to the network. We'll cut over to the demo and you'll be able to see the details. Welcome to the demo of Pyrsia. What I'm going to do is I have a recorded play of how the demo works, and I ran all the steps and recorded it. And I'm just going to walk you through the process and hope you are able to understand what's going on in the back. So let's get started. So as you will see, I created two terminals. One is called Pyrsia Node A and one is called Pyrsia Node B. And I updated the latest code so that I can build it off the top of main. I'm going to build it. As you see, this is a Rust application. And what I'm going to do is I'm going to set up two peer nodes on my Mac machine so that we can simulate what is happening on the peer-to-peer network. And then we'll also connect it to Docker. And then we'll see how the traffic flows. So first, pull the latest code, do a build. There are all these steps listed on our website too, and you will find an installer which is meant for Ubuntu. But for Mac, I'm just going to build it from source. So we have built it. Now we have a binary, and that binary goes into target, debug, and Pyrsia node. So we'll go from there. So you see, this is we'll create a Pyrsia node A, we'll create a Pyrsia node B, and we have the same thing on both terminals. We'll create a directory for node A, we'll create a directory for node B. And like I said, we'll copy over the binary and call it node A binary, and then we'll do the same thing on node B and call it node B binary. Now we have two Pyrsia nodes or binaries. Now we'll invoke them, and to invoke them, we'll add some parameters so that they know which ports to use and how to get started. Copy over the commands that are required to run the nodes. So basically, I have pre-populated the commands with port numbers, etc., so that I don't have to fumble. So you'll see this port. This is starting on a port 7888. That is the API port, and the peer-to-peer port is 44001. Since these two are going to talk over a peer-to-peer network, so we'll get it started. You will see that it started on the same port that we asked it to. It also is listening as a peer-to-peer client on the port that we mentioned. So things are going well so far. And it is listening for peer-to-peer events. There's no other peer to join for now. So it's just listening. We'll also start node B. We have a similar command, but there's a twist. We're also attaching this to the first node A. And notice the port numbers are different because we are running on the same machine. If you're running on two different machines, you don't have to bother with that. We'll just change the IP address. And you'll see that these two peers now are connected to each other, and they acknowledge adding each other to their network. Now we have the peer-to-peer network set up for Pyrsia. Now let's try to invoke some commands on the CLI. Now, if you look at the same target debug folder, there is a Pyrsia binary. That Pyrsia binary is basically the CLI. You'll see that here. So let's invoke and see what it tells us. What is the status? It is connected to one peer. And if you noticed, Pyrsia CLI actually hit node A. It is connecting to node A by default. You can change it in the configuration, but I'm just using the default for this demo. And it by default allocates about 10 GB. Again, that is configurable, but let's go with that. We don't need that much space for this demo. And there are no artifacts in it. We haven't downloaded anything or done anything. We can also do Pyrsia L. So it shows you which peers are connected and how many of them are. And you are able to verify this ID with this one. No, not this one. This is the ID of the node B. So you'll see that the node A's ID is the same as the peers, and you have it connected. Now, before we go forward, since we have the network set up, let's now configure Docker so that we can now pull Docker images. But to do that, you have to go to your Docker desktop and find the Docker engine, not the resources, Docker engine, where you can configure how the Docker daemon runs. And you see that I have configured it inline, but you can also configure it in the configuration file and then restart Docker daemon. So I'm just going to you can edit it here like I have done. And if the editing causes a change, then you need to restart your Docker desktop. But basically you added a registry mirror which points to node A, the 7888. And notice the IP address. Since this is a Mac and Docker desktop running in it, it was not able to work with the local host or 127.0.0 option. We had to use the IP address of the host machine. So that's a nuance you have to remember. But otherwise, it is as simple as just registering a mirror. And then you will be required to apply and restart. That might take a minute or two on your machine. I have done this before, so there's no setup for me. Now let's first make sure that there is no image for Alpine, and we'll download Alpine in a second. So now we're going to download Alpine and see what happens. Now on the left and the right, it will show you the network that is going on the Pyrsia network, network traffic, and you will see that Alpine was pulled from docker.io, right? Latest version of Alpine was pulled from docker.io. Because Pyrsia network did not know about Alpine, it just goes to Docker Hub and pulls it down to the network. Now let's try to do this again and see what happens. This is the interesting part. We'll remove Alpine from our Docker cache and try to download it again. And you'll see that in this situation, it did not go all the way to Docker Hub because now it found it in the peer and it was able to download it from the peer itself. So that saves us a bunch of time. Now we are actually leveraging the Pyrsia network to download Docker images very efficiently. And in case of a network failure or your inability to connect to Docker for whatever reason, you're still good because your neighbor or your nearest neighbor pulled that image. You can still work off of it. You can continue doing your CD process and delivery your software. And when Docker Hub comes back or you have established a connection again, you can start working with it and download new images. Let's try a larger image, right? It didn't exist in the cache, so it's going to go all the way to Docker Hub and pull it down. It's going to take a few seconds here. Like you can see, it took 9 seconds. And let's do the same process. Let's delete it from the cache and try to pull it again from the Pyrsia network. This time, it should not go to Docker Hub. And it should be much faster because we are basically pulling it from the local machine. And as you see, it's much faster than 9 seconds. Right? So that's how Pyrsia sort of improves the developer experience and provides a distributed and resilient network to pull Docker images. I hope you enjoyed this demo. And I'll direct you to the website for more information. Thank you. I hope you enjoyed the demo and enjoyed what we built. We have started very recently, so that's how far we have gotten. But what is coming next? The next thing that we are building on is not just the ability to pull those images, but now prove and be able to verify where these images came from. So we are building a blockchain that will record all this information. Not only will record where the image came from, but also the vulnerabilities that that particular image might be prone to, and then that will give you a way to make decisions based on information, so that you can either choose to upgrade or maybe downgrade, as the case may be. So we are building this provenance chain, as we call it, which will help you make those verifications even in an automated fashion. Other than building the provenance chain, we are also working on building a mechanism within Pyrsia where we can build a consensus over how the binary was built, and also prove that the binary was built based on some commit hash. So today we rely on the developer of an open source project telling us that they did their due diligence and ran all the tests and did everything and produced a binary from a particular Git hash, and they committed it to npm or Ruby gems or whatnot. But there is no third-party verification. So Pyrsia will come in to provide that third-party verification, and to ensure that this network is still secure. These nodes that actually end up building the binary from the commit hash will be randomly chosen, and they will build a consensus among them based on some parameters, so that they verify that they all build the same thing, and then that verified build will be committed to Pyrsia. So Pyrsia relies on current security models and sort of tries to enhance them as the case may be. So for technologies that actually are amenable to producing reproducible builds, we will actually work on the consensus algorithm and make sure that all the nodes agree and that they have built the same version. For technologies that are not so amenable to reproducible builds, we will rely on the trusted registry to tell us whether a particular build is usable, and if it has vulnerabilities, what those vulnerabilities are. We also will rely on the source of where the software came in. So we will just rely on an open source project that is on GitHub, or a verified domain that can prove where it came from. And if that domain is hosted somewhere else, then we'll verify on a private public key challenge. To re-emphasize the message, basically the infinity war is happening. So we need to do this now. It is really, really urgent. And it is not just the 3 cases that I mentioned, as I mentioned earlier. These kinds of attacks are happening every single day. Even during COVID, the hackers did not stop doing what they were doing. So supply chain is vulnerable, and we need to put these security solutions everywhere.
So what Sudhindra is saying is basically that software supply chain security is difficult because there is no one use case or one way of building things and shipping them to people. There isn't one problem to solve, as he touched on provenance and signing, reproducible builds, software bills of material, so listing what's inside my binary artifacts, decentralized distribution. So if NPM or Docker Hub or GitHub go down, how do I get my open source packages? Decentralizing that is key to solving that problem. And then all these verification mechanisms and attestations are really important because we want to be able to do this automatically. We don't want people to have to read source code to check it or do other manual checks. It needs to be automated and built into automated systems. This is such a big problem and such a big problem space that no one company is going to solve this. We need to collaborate in the open, build tools together, and work from the source code to binary artifacts to design solutions to solve these problems. That's not a one company problem. That's really a software industry as a whole need to work together on this. So Pyrsia is an open source project, as Sudhindra has told us. It started in about October 2021, so it's quite new. It's written in Rust so that we can get a bunch of the guarantees, security guarantees that we wanted. And it's still at the stage where you can have a lot of impact if you come and help us out. There's only about 38 stars on GitHub. There's under 40 of us chatting on a Slack channel. We've had about 25 public meetings so far, and there are about 27 individual contributors on the GitHub repos. I think one of the most interesting things about how the project's being run is that daily stand-ups are open to everybody, as are sprint meetings and everything else. So you can really come in. It's not just a code dump on the internet. It really is an open project where you can jump in to a meeting and change the direction of the project and be involved as as somebody who can actually drive the project. It's also following the great practice of releasing nightly versions. So if you don't want to download Rust or use the Docker build command to build your self binaries, you can just download a release and give it a quick play with before you commit anymore. So we need your help. As I said, Pyrsia is still young, and collaboration is the key to the success of this effort. When I say that we need your help, it's not just code or resources or things like that. It's feedback on what's been built. It's use cases that you have or that you see for this, or that places you have problems today. Helping writing documentation to help the next set of people get involved is great. Obviously, code is good too. So you can join us, JFrog, Logon, and Deploy Hub, who are the current companies involved with this. But it would be great to have people who contribute free time or their company's time to help work on this. I've listed out over here we have a website, we have a GitHub repo, and we're all on the OpenSSF Slack, which you can, if you just search for OpenSSF Slack, you can join that pretty easily. And as I said earlier, the community meetings from stand-ups to sprint meetings are all available on pyrsia.io/events if you'd like to join those. So thank you all for coming to our talk. I hope that you'll go and check out Pyrsia and give us some feedback. I'm looking forward to what you have to say.
Thank you very much, everyone. Bye.